Starting the matrix iteration method, first we have to discuss what is influence coefficient. For that, consider a simply supported beam as shown over here. Consider the 2 points in the beam at 1 and 2. Suppose we have applied the force over here at point 1. So this is the force at point 1. Because of the force at the point 1, the beam is going to deflect like this. When it is going to deflect like this is going to be the deflection at point 1. At the same time, there will be the deflection at the point 2. This deflection we are going to call as delta 1. 1, that is deflection at 1 due to the force at 1. Like that, this is the deflection at point 2. This deflection at point 2 is caused by the force at 1, so we are going to call it as a delta 2 1. Similarly, when we are applying the force only at 2, the beam is going to deflect like this. This force at 2 is going to cause the deflection at point 2, as well as it is going to cause the deflection at point 1. This deflection at point 2 is because of the force at 2, so we are going to name it as a delta 2 2, whereas this deflection is at point 1 because of the force at 2, which we are going to call it as a delta 1 2. What it means? Delta 1 1 is deflection at 1 due to force at 1, whereas delta 2 1 is deflection at 2 due to force at 2, and so on. So whenever we are writing delta ij, it means that deflection at I due to force at j. So you have to remember this notification, which we are going to use further frequently. So here, when we are considering the forces together, here we have considered the only force F1, only force F2, but when both the forces are acting together, what is going to happen? The point at 1 is going to deflect. This deflection will be caused because of the force at 1 as well as because of the force at 2. So let that deflection is x1, which is nothing but x1 is equal to delta 1 1 plus delta 1 2. That is the deflection at 1 due to the force at 1 as well as deflection at 1 due to the force at 2. Similarly, this deflection at 2 is going to be or is because of delta 2 1 plus delta 2 2. That is the deflection at 2 because of the force at 1 plus deflection at 2 because of the force at 2. So this is going to be the x1, this is going to be the x2. Like that, in a system there may be the number of points where we can write the x1, x2, x3, etc. Now, whenever we are considering these deflections, delta 1 1, delta 1 2, etc., generally we are going to consider the force F1, F2 as a unit force, that is the single force. And when the unit force is considered, the corresponding deflection is denoted as A1 or A11. So what is A11? A11 is deflection at 1 due to unit force at point 1. What is A21? Deflection at 2 due to unit force at point 1. So this is the deflection at 1 due to the force at 1, deflection at 2 due to the force at 1. Therefore, when we are writing delta 1 1, it is going to be A11 into the force at 1. This force at 1 is the total force. So if 1 Newton force is going to develop this much deflection, the 3 Newton force is going to develop this much total deflection. That deflection we are going to consider as a delta 1 1. So similar way we are going to write down these deflections at 1 1 2 2 etc. in terms of the A11, A12 etc. In this case, this A11, A12 etc. are called as influence coefficients. This A11, A12, A21 are called as the influence coefficient. Out of that, A11, A22, A33 are called as direct influence coefficient, whereas the A12, A21, A13, A31 etc. are called as cross influence coefficient. Therefore, the total deflection at any point xn can be given in terms of influence coefficient and the total force acting at that point. For example, xn deflection, total deflection at n point is nothing but an1 plus f1, an2 f2 plus an3 f3 and so on. Like that, we are going to form the equations x1, x2, x3 for the given masses, and those equations will be then used for the analysis. Whenever we are solving any problem, what we have to find out is, very first you have to write these equations for the x1, x2, x3. For example, you have to write the equation x1, which is going to be, suppose it is a 3 mass system, then there will be the 3 deflections at mass 1, 2, 3. So in that, x1 will be a11 into f1 plus deflection at 1, a12 due to the force at 2, a13 due to the force at 3. So this is the deflection at 1. Similarly, deflection at 2 is going to be a21 f1 plus a22 f2 plus a23 f3. Deflection at 3 is going to be a31 f1 a32 f2 a33 f3. All these equations we are going to then convert in matrix form. In this case, what we have to do first is we have to find out the values of a11, a12, a13 etc. that is the values of influence coefficient. Also, we need to find out the values of the forces F1, F2, F3 etc. In case of vibration system, these forces are nothing but the inertia forces. We know that the inertia force is given as mass into acceleration. In case of vibratory system, it is moving with SHM, so mass will be m and the acceleration will be omega square x sine omega t, which we can further write as m omega square x. So the inertia force is given as m omega square x. So inertia force at 1 will be m1 omega square x1. F2 will be m2 omega square x2 and so on. These forces and these equations will be then used or converted in matrix form, and then it will be solved by iterative method. So next we will discuss how to solve that problems.